This is part of the review, so in case you're not in class, take a look at this video. Now on this one, this review number 2, this is just telling you the stuff that you need to know. Alright, so actually you should take some time and read this. Alright, read this so you can understand what it's asking. For example, if I were to ask you for the instantaneous rate of change of f of x at x is equal to c, what am I talking about? I'm actually talking about this freaking function. Alright, so anytime you see the instantaneous rate of change, this is where you're going. Okay, so you got to be familiar with the terminology that I'm asking you, because a lot of the times the test is not that bad. You just don't know what you're looking for. Just like the first one, remember? Once I showed you, you're like, oh yeah, should have known that. I just didn't know what it was asking out of me. All right, on the next thing, remember that if I'm asking you for the derivative at a point, you use this formula. This will be faster. If I'm just asking you for the derivative function, which is this one, you're going to use what's called a formal definition of a derivative, and you will have 1 or 2 questions like this on the test. All right. Now, finally, my first year, I remember I had quite a few kids that got the following thing wrong because they didn't read this. Now, you're used to seeing this. What does that mean again? Yeah, but what does that mean? Yeah, derivative. Right, it's the derivative of x. But it turns out that this right here and this are exactly the same thing. All right, so if I were to ask you what is the derivative, right? They could actually put this on the test and they ask you, okay, find the dy dx of this function. Okay, so if you find the dy dx of this function, then that means the same thing. I know sometimes it is. Get out of here.
So can I stop like after the pep rally?
That was Charlotte, everybody, if you heard her video. She will forever be in this, imprinted in this video. All right. So anyway, again, what I'm getting at is that these two things mean exactly the same thing. Please don't miss that. Okay, so if I ask you find the dy dx, that literally means to find the derivative function, which is this one. You with me? And then I'm going to leave you alone, but look at this and see if you can figure what that says. That's just the point slope formula, written a different way. This is a derivative, right? And what did I say? The derivative at a point, that's the slope, right? Derivative, that's y, that's x. Okay. And then if you need more practice, you should probably at least look at some of this stuff and maybe look at test number 1. All right, so make sure you read all of this. I'm not going to read it for you. All right. So on this part right here, I'll take some questions here in just a second, but I want to do a few of these. All right, let me see. Okay. So for example, part E. All right, part E turns out to be 3 questions. So a lot of people are saying, well, I don't understand this. Right? They thought it was multiple choice. It's not. This is actually 3 different questions. Now, this is actually an incredibly easy question, but I can guarantee you that if I were to give you this question without helping you at all, a lot of you would miss it. All right, so if you happen to be listening on video, go ahead and pause it and try to see if you know what this is asking. All right, and honestly, there's no math to be done. All right, so I'm going to be quiet for like 20 seconds in here, but if you need to pause it, pause it. I'm going to ask the people in class right now if they know what that means, and I'll get back to you. So feel free to fast forward if you just don't want to deal with it. Have you guys done that one yet? Have you done that one, Kennedy? Okay. So look, a lot of you tend to want to do the math, right? You're just trying to plug in numbers, but it turns out you don't need to do any math. You just have to know, what does this mean? Does that look familiar to you? What is that? Exactly. All right, so this is the derivative at a point formula. Okay, but instead of f of x, they wrote h of x. And instead of writing f of c, they wrote h of d. But that's the same thing. Are you with me? So again, that's the derivative at a point. Good. So what does that really mean? Now we know this is the derivative, but what does that really mean? Slope. All right, as simple as that. We're talking about a slope. So now, if the slope of the tangent line on f of x is 0, then what can you say about that? As many things as you can. Now, and we're going to talk about just specifically about f of x, not the derivative. So if I have the slope of the tangent line, Could you say that's a horizontal tangent? You can say that. Perfect. Either have you're going to have a max, a min, I guess I should say or minimum, or perhaps neither. Right? But that's good. You have a horizontal tangent, which then means you have a max, a min, or neither. Perfect. All right. Now, if I have a derivative, remember that means derivative. So forget about what all those little different symbols here. It doesn't matter. This is just the derivative, which means the slope we just found, right? This will find the slope of the tangent line at a point. What if the derivative was negative? What can you say about f of x?
Decreasing.
Decreasing. Perfect. Really, there's not much more you can say, all right? And by the way, I got to write, this is for f of x, all right? So f of x is decreasing, right? Not to get that confused with the derivative. All right, what can you say if the derivative, remember that's the derivative. I guess I should point at the camera. This is the derivative. If the derivative is positive, what can you say about f of x? Increasing, yeah. So these are the type of questions you need to think about, because that question right there, not that hard, but if you don't know what you're looking for, then you're screwed. All right? Okay, let's see if we can go, let me see where I want to go. Okay, so let's go to the very back. All right, because that kind of goes back to what we did on that quiz a little bit. And by this point, hopefully you know how to do that, right? Okay. Now, I know that some of you may think the limits are just here to fill this page up, but it turns out that the limits are going to be on your test. All right, so if you're doing this, and if you're listening to a video, see if you can do this in the next 10 seconds, because that's how long it should take you to do this limit. Anytime you have the limit going to infinity, you're going to do the horizontal asymptote rules, right? So for this one, which one's bigger?
Equal.
They're the same,
So
right?
Top coefficient.
Right. It's Betsy, right? Remember, you're going to use the horizontal asymptote rule. So this is Betsy, which is the coefficient, the ratio of the coefficient. Excuse me. So that's 2 over 1, which is just 2. See? That easy. You should know how to do that. Okay. Now, on number 8, what should I do?
You try to plug it in, but it won't work.
Right. You always try to plug it in first, and if it doesn't work, you need to factor. It turns out you can factor and solve for that one, but I'm not going to get to that, right? Again, I already sent you the solution, so make sure you look at them. Okay, you could possibly have something like 3 or 4. Now, if this was multiple choice, okay, if you don't have to show much of the work, a lot of you have already figured out what the answer is going to be, hopefully without even writing one thing down. All right, so if you're listening to a video, check it out, see if you can do that. And then while they think about it, I'm going to do it the mathematical way, which again, if it was multiple choice, you wouldn't have to do that. Okay, so remember that I cannot factor this 5x, so all I can do is multiply top and bottom by 5. And on the next step, I am going to move that 5 I'm going to move this bottom 5 to the bottom of this this ratio right here. So 5x over 5x. So the sine of 5x over 5x, the limit as x goes to 0 of this right here, this is going to be a 1. So really you have 5 times 1, which is just 5. Are you with me? But maybe a lot of you did the work without, if it was multiple choice, I personally wouldn't do that much work. I know that's going to be 5. And then hopefully you know what number 4 would be. What do you think 4 would be? What?
1 over 5.
1 over 5? You sure? Yeah, it's 1 over 5. All right, so yeah. On this one, I find it easier because you can just pull out the 1/5 all the way out if you want. And then you would have this. And yes, I can factor the 5 out of the bottom because it's not attached to the sine function. So this is just 1. Like I said, if it was field response, then maybe a little bit. But if it was just multiple choice, then no. Okay. All right, so that's not really what I wanted to talk about, though. What I really wanted to talk about is this one, all right? Because this one actually will help you. And this one, they're asking us to sketch. All right, so number one is asking us to sketch. So to do that one, let me see if I can find a different colored pen here. Okay. All right, first, what you should do is to write your sign analysis for the derivative. Right, and the sign analysis for this one, remember that I'm going to include those points because, remember, what do those points mean here in class? Max or mins possibly, right? This is where my horizontal tangents are located. So I'm actually going to transfer those down here. And then this would be, remember, above the x-axis for the derivative, that's going to be a positive. Down here is going to be a negative, positive, negative. Everybody with me? Okay. Now, that one then hopefully leads you to the sign analysis of f of x. Sign analysis of f of x is going to be very similar. And really, the only thing that's going to change is you're going to write increasing, decreasing, increasing, decreasing. All right? Before we even start to sketch this, all right, I need you to think about this. What degree is this? Degree 3. So my f of x should be degree what? Should be 4. Remember, I'm going up, right? I'm going from the derivative to f of x. I'm going to go up. Negative or positive? Negative, right? Because that's like your left hand up and your right hand down. All right, so since this is negative, my derivative, this function is negative and is degree 3, then f of x should be degree 4, and it should be pointing down. So it should be almost like an M looking thing. Are you with me? So here comes the sketch then. Now, somebody did ask me this, like somebody said, well, how do I know, like basically, how do I know how far up to go, how far down on the y coordinates? And the answer is, I don't know. You don't know either. So this could look slightly different for y'all. Remember, this is increasing between negative infinity and at negative 2, I have a max. I'm going to decrease all the way into 1. There's my minimum. I'm going to increase all the way up here. All right, so notice again that this was my max. I went from positive to negative. And that's a lot easier to see on this stuff like this. Positive to negative, I have a max. Negative to positive, I have a min. And that min is right here. Does that make sense to y'all? So if you're looking at the quiz, hopefully, I like this example because it kind of puts it all together for you right in front of you. Okay? Is there any questions from y'all? Still got about 7 minutes.